Okay, so today we're going to mix two ideas together. We're going to use some of our algebraic expressions and our area model together. So by the end of today, we should have two techniques for multiplying algebraic expressions together. And we're going to give a fancy name to that: distributive property. Okay, so the nice thing is it's using information or knowledge you already have. We're just going to combine it in a slightly different way. Okay, so if we ask for an area model for multiplication, if I had 34 times 41, you could break that down however you felt. I'm pretty comfortable with some of these things, so I'm going to write down 30 plus 4 on one side and 40 plus 1 on the other side. If I multiply the 30 and the 40 together, I get 1,200. If I multiply the 30 and the 1 together, I get 30. If I multiply the 4 and the 40 together, there's my 160, and 4 and 1 is 4. Okay, so now all I have to do is add those together. So I have 1,200. I'm going to do these two together. So there's 1,360. I'll add these two together with an additional 34. I add those up, and I get 1,394. Okay, so we're going to take that idea and we're going to remove the numbers and we're going to put in some variables and some unknowns. But what I want to highlight is the outside of the two black lines are what we call the dimensions. And whatever we find on the inside, we're going to call the area. So if you think back to here, okay, so the outside, these are the dimensions on the outside, 41 and 34. If we were to actually lay a grid on here, if you were to break this up into a grid and you had to count all the squares, you would find there are 1,394 squares. Okay, so we try and avoid doing those types of techniques because that's really tedious and time consuming. So this is where our multiplication comes in handy. So a quick refresher on some definitions. Monomial is one term, so you'll notice these are all the same terms in terms of this is all just little 5 ones like this. Okay, 9x would be 9 of the same size shapes from our algebra tiles. Binomial is two different terms. Okay, so we have unlike terms, so we can't combine them together. And trinomial is 3 terms. Okay, and they're all unlike, so you can't mix them together anymore. So we have done algebra tiles with our zero principle and our 2-color counters. We've done like terms, and we're into part 3 where we could do the distributive property. And then the good news for you is most of these ones are done in grade 10. Okay, so quick highlight, just a reminder that we have 3 different size shapes. So we have an x squared, an x, and a 1. And then we have the negatives of them, negative x squared, negative x, and negative 1. And the zero principle still applies. A positive x can be canceled by a negative x because they are the same size shape. All right, so let's just do a quick refresher. What is the value of each group? Well, this would be 2x squared plus 3x plus 4. And you can't do any more with that because those are all different size pieces, so that's where we stop. We'll go down here. Make sure we give myself a little more room to write. Okay, now we may have to observe and see, are there any zero pairs here? Well, yes, there are. So these two would cancel. I can't see that. Let's try that one. Those two would cancel. These would cancel. And those would cancel. Okay, so if we look at this, all we have left is negative 1x squared plus 1x minus 1. So even though there's a whole bunch of terms there, because a whole bunch of them cancel, this is what it's actually worth. Okay, so there's only one rule we have to really worry about on the algebra tiles, and I've sort of mentioned this before, and that is that the like side lengths are the only things that can touch. So let me just highlight that. We'll go yellow. So you'll notice these algebra tiles right here, they have the same side length in their physical representations. So they can actually go together because that means those are the same value. Okay, this one here, these are both 1s, so they can touch. What we can't do is this. Right here, this is incorrect. Okay, because that 1 here on the bottom doesn't stretch the entire length of the x, so we can't stack them along there. So that's the only rule you have to worry about, is that only sides of the same length are allowed to touch. Okay, and if you can remember that, then these are pretty straightforward to work with. So I've set these up for you. So the instructions are expand or multiply. So these are both dimensions. Okay, so we're multiplying these two things together. They're both dimensions. I've set up 3 down the left side and x plus 2 across the top. And now what's nice about these is you can see pretty easily what would fill this box underneath here when we multiply a 1 and an x together. Well, the only thing that fits is an x. Okay, and then we can see, hey, there's actually 3 of those that have to go in there. And now to fill the remaining spaces, we have 1 times 1, which is a 1. And we fill these in like such. Okay, so now we can look at that. The answer here is the area inside, so everything that's inside those black lines. So the answer here is 3x plus 6. Okay, so we could also view this way. As multiplication. 3 times x plus 2 means I have an x plus 2 plus an x plus 2 plus an x plus 2. And if we collect like terms, we would get 3x plus 6. Okay, so we've got a couple different strategies to work with. All right, let's try some trickier ones. Expand and multiply. So expand has an x in it. It's a good indicator that we should multiply something. So I've set these up already. On the left side is my -4. Across the top is the 2x minus 3. Now the only thing I have to watch here, I have a -1 times an x to fill that first space. So this becomes a -x. Okay, and then I'm going to have a, oops, grab the wrong term. I'm going to have a bunch of -x's that fill there. I'll try and go quickly here. Let's clone those. And now I have to be careful, because now I have -1 times -1, which is a +1. Like that. And again, I'll just try and clone those. Whoops. Clone those really fast. So I got clone. Clone. And now if we count up what we have for an answer here, we have 8 -x's plus 9 1s. Okay, now some of you might, oh, not 9. Did I write it down wrong? 2x minus 3. 12. I can't count. That's what it is. Ha! There we are. That's better. So we have -8x plus 12. Now some of you might start to see a bit of a shortcut here. That's awesome. Don't say anything just yet. Oh, okay. Now here's where things get tricky. So now I have an x on one side, 2 x's on the top, and 4 1s on the top. When I multiply an x times an x times an x is an x squared. Uh-oh. So we're going back to our exponent rules, and now we have to be really careful, because from multiplying, the exponents can change. That is really, really important to follow. So that first term is an x squared. The next term is an x squared. And now I have x times 1. So I have a bunch of x's I can put in there. And so this is where things start to get complicated for students, because we are now mixing multiplication and addition, and they have different rules. So this would become 2x squared plus 4x. And this is where the algebra tiles, when you're learning, can be super helpful, because you can physically see the differences and how things change. Okay, so I will be highlighting where you're going to have problems as I go along. Please pay attention to them. -2x down the left, 3x minus 1 across the top. Let's try it. -x times +x. That would be a -x squared, and you can see how it fills that space perfectly. Okay, and then I have a second one down here. I got a couple more. So once you do it once, starts to get a little easier to see. I'm running out of space here. And now the last part is negative x times negative 1, and we should get a positive x for that last piece. And so my answer, or my area, when I multiply these together, is negative 6x squared plus 2x. Okay? Now, there is a shortcut, and we're going to take a look at this, and then we're going to go back and check the ones we just did. It's called the distributive property. And if you look, you can see this a value here is multiplied into both terms inside the bracket. So a times b becomes ab, a times c becomes ac. So let's just go back and do a quick check. If we did distributive property, and we distribute to both of those, 3 times x is 3x, 3 times 2 is 6. Hey, it worked on that one. Let's check this one. Negative 4 times 2x, negative 8x. Negative 4 times negative 3, positive 12. Hey, it looks like it's working. Oh, now here's where we got to be really careful. X times 2x, 2x squared. Because we're multiplying terms with exponents, remember there's little ones on here, those exponents change. X times 4, 4x. So it looks like we're on a roll. So let's go and try that. We are going to distribute. And while you're learning the shortcut, this is what I would strongly recommend. You write out the 2x, you write out the x. You write out the operation of addition, you write out the 2x, you write out the 8. And now you solve these as two small little problems. Well, right here, these guys both have 1s as their exponents. We are multiplying powers, so we should add the exponents. So this becomes 2x squared. Over here, there are no other x's in the second term, so I don't have to worry about those. I have 2 times 8, which is 16x. Okay, so this line right here, when you're learning, is super important. Okay, whoa, this has no numbers in the bracket. What can we do? Well, we multiply it in. So this gets multiplied in like this. So 2 times a is just 2a. 2 times b is just 2b, and 2 times c is 2c. Okay. Ooh, now this one's nasty. There's lots of exponents. We have lots to worry about on this one. So let's take our time. We're going to write, there's the first one. So 2x cubed times 3x squared. Then we're going to have 2x cubed times 5x. And now we're going to slow down and do each one of these as a small little problem. So within here, I have a 2 times a 3, which is a 6. And now I have an x cubed times an x squared. Okay, so if we go back to our exponent rules, you have multiplications of powers, so you have to add the exponents. X to the 5th. Okay, next one. I have 2 times 5, so there's 10. And again, I have an x cubed, and if you need to, put the little placeholder of a 1 on there. Multiplication of powers, this becomes x to the 4th. Okay, so there's nothing there that's outside your skills, but you do have to slow down and really go slowly to watch the details. Okay, if you want to pause this and try it, this is a tricky question. Okay, so I'm going to distribute to all of those. I'm going to write out this line because I'm learning and I know that I'm going to have some problems. And you'll notice a couple things. I used adding in between because adding never changes the signs. Okay, so this allows me to deal with all of the positive and negatives within the brackets, and I'll worry about the final answer, the signage, when I get closer to that line. All right, so first term, let's do it in black. Negative 3 times 5 is negative 15. X squared times x is x cubed. Second term, I have a negative 3 times a negative 6. So I know a negative 2. I spoiled it there. Negative 3 times negative 2 is positive 6. X squared times x squared is x to the 4th. Okay, and then lastly, we'll do this last one in green. A negative 3 times a negative 1, you can put a placeholder in there, is a positive 3. And an x squared times an x to the 5th is x to the 7th. Now when we look at that last line, none of those are like terms. You can't do anything more. You stop. Okay, so here's a few questions to try. Right here. Please, please, please watch out for what I have written over here. X times x, there's little placeholders of 1s on here, is x squared. That's an area model because it's multiplied. Okay, x plus x. Okay, this is collecting like terms. Okay, it's a different model. So this is just 2x. So please note the difference. When we are adding, the exponents don't change. When we are multiplying, the exponents can change. That's a huge, huge concept. Okay, thank you for tuning in. We'll stop it there. I know there'll be more questions in the future.